Okay, so this is a really nice chart that does some basic graphing of what type of metamorphic environments we would expect to have what types of pressure and temperature combinations. If you look in the top, you see that blue area says hydrothermal metamorphism. So we talked about that as being superheated water. And it generally has a fairly low pressure and a fairly low temperature, right? As we move on in that direction, we see contact metamorphism. And if you think about that type of environment, we've got a great amount of heat that's coming up from the subsurface in the form of a pluton, some sort of liquid magma. And it would have a very high temperature because that stuff is really hot, but it would have a low pressure, right? Because it's actually pushing stuff up rather than something being buried with a lot of weight or two continents colliding together. If we move down into the purple area, we see that it's regional metamorphism. Regional metamorphism being that two continents are colliding, and you can see that that ranges from a low grade up all the way into a high grade. So that particular environment can have lots of different pressure to temperature combinations. And finally, we talk about burial and subduction zone metamorphism, that green area, that it can also have a pretty big combination. In fact, it can have the highest, where we see down in the bottom right, we've got the highest pressures and the highest temperatures. It's also a little section there for not found in nature. So what we want to do is we want to be able to recognize what rock comes from what environment, and then back that up, well actually what rock comes from what grade of metamorphism, and then back that up into its environment so that we can dissect the geologic history of the area.